Hello students, welcome to Math 1680, Elementary Probability and Statistics. Lesson 1 consists of 3 sections. 2 sections that are necessary but not very important, and the last section that is important. I have to follow steps, so let's begin with section 1. I said already, not very important, but they are necessary nonetheless, so let's go with these. The first question here is, what is statistics? After all, this course is statistics. What is it? Here's a one-line answer. According to a certain textbook that I consulted, the author says, statistics is a science of collecting, organizing, summarizing, and analyzing data. According to another textbook that I consulted, the authors say, statistics is a science of collecting, describing, and interpreting data. Either way, the key word here is data. In short, statistics is a science of data. Now, how do we study data? Depending upon that viewpoint, we can classify statistics into descriptive statistics and inferential statistics. Descriptive statistics focuses upon the collection, presentation, and description of data, and we don't use a lot of mathematics here. Inferential statistics, on the other hand, focuses upon the analysis of data and the decision making, and here we use a lot of mathematics. And this course is a math course, so of course we are going to focus far more upon inferential statistics. Indeed, we're going to spend about 2.5 weeks about descriptive statistics, and the rest of the semester we're going to study inferential statistics or a closely related topic. Let's begin with some examples here, and here's a brief overview. Here's an example of a descriptive statistics. Here's a data presentation, and the data is about teens using cell phones in class and using cell phones while driving. And we have all these percentages, those are data, and even the picture is playing a role. After all, this data set is about teens using cell phones while driving, and here's a picture of a car, so they are relevant. So even the picture is playing a role. All these kind of things are examples of descriptive statistics. Maybe it would have been a little bit more straightforward if I see a picture of a car wreck. Maybe that's too strong. Let's go to the next example. Here's an example of an inferential statistics, but at first glance, they don't look any different. We have percentages here, like previously, and we have a picture here. This one is about what kind of traits employers are looking for from potential employees. And we have a picture of a paycheck, and then we have percentages of all these traits. Now, all these percentages arranged in terms of this pie chart versus these percentages arranged in the bar graph, and then the picture of the car versus the picture of the paycheck. They don't look any different. Percentages are percentages, picture is a picture, they're all relevant, they're all descriptive statistics. And the answer is yes and yes. The inferential statistics here is all the way down here, the last sentence. This is based upon the survey of 1,043 hiring managers, and the margin of the error is plus or minus 3 percentage points. That part is the inferential statistics. What does it say? It says these percentages here are actually the consequences of a certain statistical inference. And in statistics, nothing is accurate. Everything is error, plus or minus some percentage point, in this case 3 percentage points. And then this margin of error, as a matter of fact, can be controlled by the sample size. And the sample size is larger than more accurate, so smaller margin of error and vice versa. All those kind of things are done in inferential statistics, And we're going to talk about these kind of things in week 9 from chapter 8 of our textbook. For now, let's just consider it as a brief overview. Okay, we went through some terms and examples, but we need some more terms, and here they are. Population and sample, they're important, so they are colored accordingly. And then there are some more: variable, data value, data, experiment, observation, and then parameter and statistic. Again, they are colored, so they're going to be important. What are those? A population is the entire collection of individuals or objects or events whose properties are to be analyzed. So the population can be a physical population, or sometimes it can be more abstract. Here's an example. If you are in healthcare, then you're interested in BMI, body mass index, of all US men of age 60 or higher. And higher body mass index there is going to be a bit troublesome, especially for older people, and you're interested in those kind of things. Now, in this case, the term population pretty much coincides with physical population, the dictionary meaning of a population. Okay, we are talking about only men here in this case, and age 60 or higher, but still, more or less it's a population. We are talking about a large group of people. Let's go to the next example here. All possible measurements of the mass of the Earth. At first glance, that doesn't look like population. We're talking about infinitely many possible measurements here, because you can repeat any kind of measurement over and over and over again indefinitely. Still, we call population. We use the same term because the term population is an abstract concept used for statistics. Basically, and something that I want to analyze, basically. And it is very difficult, if not impossible, to get it directly. So what do? We use sample, which is a small subset of the population. Instead of analyzing everybody, just select 1,500 people, randomly selected, a sample of 1,500 men of age 60 or higher. That's a sample. Instead of considering every possible measurement, where infinitely many of them are possible, we just select 25 measurements I just did, and considering the average and things like those. Yes, that's a sample. So population versus sample, big versus small. Now, all those numbers associated to population is called a parameter, and we use Greek letters for that. And all those numbers associated to sample is called the statistic, and we use Roman characters for those. P goes to P, S goes to S, blue goes to blue, red goes to red. Population, parameter, sample, statistic. Remember these, please. Now, what do you mean by a numerical value? Basically, what is a value? Well, here we go. A variable is a characteristic of interest, and this concept here in statistics is very different from the same term variable in algebra. In algebra, we are talking about real numbers there, but in here, it can be anything, as a matter of fact, any kind of characteristic of interest. Of course, in the previous example, the BMI of all US men of age 60 or higher, if you're studying those kind of things, the variable here is, of course, the BMI, the body mass index. And then, if you're interested in measuring the mass of the Earth, variable is the mass of the Earth. Both of these are quantitative. They are both numbers, but it is possible to consider qualitative variables as well. For example, in voting model, you can consider all US adult women who are voting and what party do they support? Democrat for D, Republican for R, and independent, undecided, there could be many, and They're not numbers. You can consider qualitative variables as well. All those are variables. Everything that varies is variable. For each variable, and you can find a certain value by appropriate measurement, and each value is called a data value. For example, a BMI of one man you just measured, or the one measurement of mass of the Earth you just did. Each of them is called the data value. Now, if you have a bunch of data value put together, that's called data. As a matter of fact, data is a plural term in Latin. And the singular term for data is datum. But then again, datum is correct, but it's a bit too Latin. So people call it data value. I may end up calling datum one way or the other. Sometimes I do that. If I say datum, I'm meaning data value. Now, how do you get data? You either get by experiment or by observation. Experiment, typically you can control the environment. Observation, you can't. And without any kind of attempt to influence it, you just get those data. Okay, those are basic terminologies. Now, as for these, if you have pretty good idea what those are, then that's fine. You don't really have to know all these 100%. As for the color terms, population sample, parameter, statistic, you gotta know 100%, absolutely certain. Now let us talk a little bit more about these, the black terms, variables. Variables exhibit variability. Each data values differ, and the difference is called variability. But the variability can be either numerical or non-numerical. It can be classified like this. A variable can be classified into either qualitative or quantitative variables. Qualitative, no number. Quantitative, number. Qualitative variable can be classified further into nominal versus ordinal. Nominal, they're just names, like voting example, D, R, I, those kind of things. They're just names. Ordinal, there's a certain order. For example, if you obtain letter grade, A is better than B, B is better than C, C is better than D. They're ordered, so that's ordinal. As for quantitative variable, you can have either discrete variable or continuous variables. So BMI example or mass of the Earth, they're all continuous variables because they are all real numbers. If you count the number of people, then it's going to be discrete variable because you can have only integer number of men or women. Well, depending upon those characteristics of those variables, we can have different types of measurement. Nominal variables, nominal level measurement, ordinal variable, ordinal level measurement. Nominal level, for example, for Democrat or Republican, how many of those people are supporting. So you can do counting or you can find their percentages, those kind of things. Ordinal variables, you can do a little bit more. For example, you can assign GPA to those. Say A is 4, B is 3, kind of like those. Quantitative variables, you can have either interval level or ratio level measurement. Oh my goodness, I'm not going to talk too much about those. If you're interested, you can read the book. I'm never going to come back and talk about those interval level and ratio level measurements here, at least not in this course. Okay, so much for section 1. And another warning here, we went through a lot of terms because many of them are necessary, not because they are important. Remember that. The really important part here is section 3. Otherwise, you just follow through, read through, get some idea, and that's it.